All right, so now we're going to talk about solutions in terms of electrolytes and non-electrolytes. Okay, so first let's define what we mean by an electrolyte and a non-electrolyte. So an electrolyte is a substance that conducts electric currents in water. And as we'll see in the next slide, this is due to the fact that these solutions have a lot of ions. Non-electrolytes are substances that do not conduct electricity or electric currents in water, and this is because they have no ions in solution. All right, so we're going to break electrolytes down into three different categories. We have strong, weak, and non-electrolytes. Now, strong electrolytes are going to be substances that completely dissociate or separate into their ions when they are dissolved in water. These are going to be things like strong acids and bases and our soluble salts. So having that chart, that solubility chart, and also the list of your strong acids is going to be very helpful for this. Your weak electrolytes are slightly dissociated in water, and what they contain are mostly uncharged molecules. And these are going to be your weak acids and your weak bases. So the example here is ammonia, and ammonia exists dissolved in water under equilibrium. When ammonia reacts with water to form ammonium and hydroxide, what we find is that most of that substance stays in its ammonium, its neutral form. And then of course we've got non-electrolytes, and these do not dissociate at all. These are going to be covalent substances, and they do not conduct any electricity. So this will be things like sugar. So if I dissolved sugar in water, it's not going to conduct electricity. Pure water, pure H2O, does not contain enough ions to conduct electricity. So things like sugar, alcohols, water, these are not going to be good conductors of electricity. And what you can see is in the image that we have over here, we have an image of strong electrolytes, weak electrolytes, and non-electrolytes. And so those strong electrolytes are going to have lots of ions in solution. Weak are going to have very few ions in solution. And that's shown here with that positive and negative charge here being connected, meaning that that's neutral. And you can only see in here one of those particles is actually broken into its ions. And then of course non-electrolytes, no ions at all, so it is not going to conduct electricity. All right, so here's a cool demo. Hopefully we'll actually be able to see this in the classroom. So if we take a light bulb and plug it in, but notice that one of our wires here is not completely connected. So this means that if there are no ions in solution, there's no way for that electricity to complete that circuit, or there's no way for that circuit to be completed. So for non-electrolytes, you are going to see that, again, not going to conduct electricity. If we have strong electrolytes, so that's this guy here in the middle, lots of ions, definitely going to conduct electricity. And then if we have weak electrolytes, it will still conduct electricity. It will still make that light bulb glow, but just not nearly as much as the strong electrolytes. Okay, so one of the reasons why it's important for you to understand when something's an electrolyte or a non-electrolyte is because of how important they are to the functioning of our bodies. And not only is it important for you to be able to tell if something is an electrolyte, but we're going to be talking about how we can determine the overall charge that is contributed by that particular electrolyte. And this leads us to talking about equivalence. And the equivalence is the number of moles of charge that a mole of ions contributes to a solution. So the number of equivalents per mole of an ion is the absolute value of the charge of that ion. And just to remind you, absolute value, that means that if something has a positive charge, we just look at it as that charge too. So for example, or if something is a negative charge, we just make it positive. So we're just looking at the overall value of the charge on that ion. So for example, the sodium ion has a +1 charge. So therefore, 1 mole of sodium ions is going to give me 1 equivalence. Calcium has a charge of +2, and that is going to give me, if I have 1 mole of calcium, that is going to give me 2 equivalents. Chlorine or chloride has a charge of -1, and so 1 mole of chloride is going to give me 1 equivalence. Okay, and so this is something you may actually be dealing with in your careers. When we're talking about electrolytes and we're talking about the useful applications of these, we're talking about, or we could be talking about electrolytes in blood plasma and IV solutions. And these are generally reported in milli equivalents. Remember that your milli equivalence, or milli, represents or stands for thousandths. So 1,000 milli equivalents is going to be equal to 1 equivalent. It is very important that the positive ions must balance out the negative ions in solution. So for example, if I had a solution of potassium chloride that had 40 milli equivalents of potassium ions, it must also contain 40 milli equivalents of chloride ions. We'll definitely be doing some practice with this in class.